Welcome to qnawire.
Here we want to calculate what is going to be the impulse, which I'm going to use the letter J, which is going to be defined as the integral of the force differential of time. In this case, we're not going to have any unit for force, so what we want is to calculate the functions corresponding to the force on the time from 0 to 3 seconds, from 0 to 3 milliseconds, and from 3 to 7 milliseconds. So, in this case, the impulse would be equal to the integral from 0 to 3 times 10 to the minus 3, which is 3 milliseconds, of the function of the force as a function of time, differential of time, plus the integration from 3 times 10 to the minus 3 to 7 times 10 to the minus 3 of the second function of the force as a function of time, differential of time. So the first part is going to correspond to the straight line over here, and the second part is going to correspond to this second line. Let me label this as force. Let's say force 1 and force 2, respectively. So first of all, to find the function of force 1, what we want to calculate, first of all, is going to be the slope. The slope for this straight line is going to be equal to delta y over delta x. In this case, it would be max force minus, in this case, we're going to have 4/7 of the max force divided by delta x, which is 3 times 10 to the minus 3. And with this, we know that the slope would be equal to 3/7 of the maximum force divided by 3 times 10 to the minus 3 seconds. In this case, I'm going to leave it like this just to get all of the results correctly. We can also simplify it a little bit if you want. This would be equal to 1000 over 7 times the maximum force. And this would be already in units corresponding to newtons per second. And now the B part of our straight line is going to be directly equal to 4/7 of maximum force. So the equation for force 1 would be equal of an equation of the time y equal mx plus b, in which we're going to get 1000 over 7 maximum force times t plus 4/7 of maximum force. With this, we can calculate the first integration. So the integral from 0 to 3 times 10 to the minus 3 of 1000 f max over 7 t differential of t plus 4/7 of maximum force times the integration from 0 to 3 times 10 to the minus 3 dt would be equal to, I'm going to factorize f max of our result for both of the cases, and the first integration is going to yield 500 over 7 t squared. Notice that I have already divided by 2, evaluated from 0 to 3 times 10 to the minus 3, plus 4/7 of 3 times 10 to the minus 3 seconds. Knowing that the value of F max is equal to 61.3 newtons, we verified that it was correct, 61.3, yes. The result is going to be, would be equal, for this first impulse, to 0.1445 newtons second. Now for the second section, section in purple, we can actually do the calculation a little bit easier because this is nothing but a right triangle. So The height is going to be F max. The base is going to be equal to 4 milliseconds. So the impulse for the second part, which is the integral from 3 times 10 to the minus 3 to 7 times 10 to the minus 3 of F2 as a function of t dt, would be equal to the base, which is delta t, F max times the base, which is 4 times 10 to the minus 3 seconds, divided by 2. So 2 times 10 to the minus 3 multiplied by 61.3 newtons, which is 0.1226 newton second. So now we just need to add both of the values for the impulse. So the total impulse for the whole movement is going to be 0.1226 plus 0.1445, which is 0.2671 newton seconds. In this case, we're asked to give our answer with 3 significant figures, so this would be equal to 0.267 newton second. And with that, it would be all. And just a final comment, be careful when you're uploading data, because there was like some personal information, so I decided to erase it. Okay? And with that, it would be all. Thank you very much and have a good one.